Let's try to solve some linear systems. Linear systems. Linear means that the equations given are of a line, degree 1, like y equals to mx plus b. And system means more than one equation, right? So if there is more than one equation, then we form a system. Okay. Method used is substitution here. Substitution is, you can see here we have two variables, x and y. Now, to solve for two variables, you definitely need two equations. Now, to solve for two equations simultaneously and two variables, we can follow one of the two methods. One method is substitution, the other one is elimination. It's a matter of choice, given the equations, to choose the one which is most favorable and easier to use. In this kind of equation, when we know y equals to something, and the second equation is something else, x plus y equals to, let's say 7 here, then since we know what y is equal to, we can substitute this value of y here. And then we will have equation in just one variable, x, and then we can solve for x. Once we find x, then we can substitute the value of x and find y. In this particular equation, we know x in terms of y. So it's easy for us to substitute x here with these values, and then we'll have equation in y. Solve for y and then get x. This equation is not a very good equation to do substitution. This equation is good for elimination. If we take away one equation from the other, then y will vanish. Do you see? Y minus y becomes 0, and we get equation in just x. So it becomes easier to eliminate one variable and find the other. Well, here we will use substitution for this also. Okay. Then you will appreciate which is better and when. Let's start the process. So we have equations here. Let's name them. Let's say this is my equation 1 and this is my equation 2. Right? And what first step is? From 1 we know y equals to 2x plus 1. So what we will do? We will sub 1 in 2. Right? So we'll sub value of y from 1 in 2. If we do that, then we get x plus, instead of y, I'm going to write 2x plus 1. 2x plus 1 equals to 7. Do you see that? Now we have equation in just one variable, and the variable is x. So when we combine the like terms, here 3x plus 1 equals to 7. Now, so 3x equals to 7 minus 1, which is 6, right? And x equals to 7 minus 1 is 6 divided by 3, which is equal to 2, right? So we get x value. Once we get value of x, we can substitute this value back in equation 1 and find y. So we get y equals to 2 times 2 plus 1. 2 times 2 is 4, 4 plus 1, 5. Therefore, solution of this system is a coordinate point where x is equals to 2 and y equals to 5. We write this answer as 2, 5. So that's our solution. Now, you can check if this is the right solution. To check, we'll substitute 2 for x and 5 for y. 2 plus 5 is 7. So you get the answer 7, correct? Here also we can check. If we substitute 2 for x, we get 2 times 2, 4 plus 1, 5. Yes, it works. Let's solve the second equation. Follow the same method. Let's number the equation as 1 and 2. Now what we will do? We will do sub, this time x value, right? We'll say substitute, I'm just writing in short form, x from 2 in 1, in equation 1. Okay, so if you do that, then what do you get? We get 2 times y minus 4 minus y equals to 4, right? So we have a variable, just one variable in this equation, that is y. Just open the bracket and solve for y. So we get 2y minus 8 minus y equals to 4. 2y minus y is just y, so we get y. And we can take 8 on this side, equals to 4 plus 8. So y is equal to 12 for us. Is that okay? Now we can substitute 12 in 2. So let's say this is our equation 3. So what we will do? Sub means substitute value of y from 3, I am writing in short, in equation 2 to solve for x. Okay, so then we'll solve for x. We get x equals to y minus 4, and y is 12 for us. So 12 minus 4 equals to 8. Therefore, what is our solution? Our solution is 8 for x value and 12 for y value. So we get our solution. Correct? You can check. We got this value from equation 2, so we should check in equation 1. If I plug in 8 here, 8 times 2 is 16, and 16 minus 12 is 4, so that's correct. Okay. Now, as I said in the beginning itself, third equation, which we are working on, is not a very good equation to use for substitution because we don't directly know what x and y is. Now, let's solve for 1. Let's say y is equals to, so let's say this is my equation 1, this is my equation 2. So from 1 we can solve for y, and we say y equals to 3 minus x. So let's say this is our equation 3. Now when we know y is 3 minus x, we can substitute this in 2, right? So we'll write 2x plus, instead of y, I am substituting 3 minus x, right? 3 minus x equals to 0, right? So what did I do? I used equation 3 and 2, right? So what did we do? We did 3 in 2. Is it okay? I'm writing in short form just to give you an explanation of what I did. It is good to write on the right hand side, okay? 2x minus x is x, right? So we get x plus 3 equals to 0. And from here we can say x is equals to minus 3. Once we find x, let's say this is equation 4, we can substitute 4 in 3 and get y. So y is equals to 3 minus x value is minus 3. So 3 minus minus 3 is 6. Now, so these are the values of x and y. So I should write in the coordinate form. It is minus 3, 6. Let's check it here. If I put x as minus 3 and y as 6, do I get 3? Yes, I do. So that means it is the correct answer. Okay, you should understand one more thing. In all the 3 examples which we did just now, we got a solution. But it is not necessary that you will always get a solution. Correct? In linear systems, 2 lines are intersecting. Is it okay? So when 2 lines intersect, there are different scenarios. For example, let's see this. 2 lines could be parallel. Is that okay? One line like this and the other line parallel to this. In that case, how many solutions do you expect? They don't intersect at any point, so number of solutions are 0. Example for this could be, for example, it could be y equals to, let's say, x minus 1 and y equals to x plus 2. Now here, do you see the slope is same? If the slope is same and the y-intercept is different, that means they are 2 separate parallel lines. So in case of parallel lines, they will never intersect. And so we will not get a solution. Correct? There could be a case like this also. That is to say that one line is like this and the other one is exactly over it. In how many points do they intersect? They intersect an indefinite number of points, infinite points, all the points, because they are practically the same lines. For example, I could write y equals to x plus 1, or I could write x minus y equals to, so I'm writing x minus y equals to minus 1. Okay. Sometimes what we do is we multiply them by a factor. We don't make it so simple, right? These are practically the same equations rearranged, right? I could have written like this also. 2x minus 2y plus 2 equals to 0, right? Something like this. So these are same equations and they will have infinite number of intersection points. The equations which we dealt with over here were not parallel. You see, their slopes were different, right? So we had just one point of intersection. For example, if you kind of sketch this one here, let me sketch it here. Now here, what is your y? Y equals to 2x plus 1. That means slope is positive and y-intercept is positive 1. So we'll start from here and draw a line like this. Is that okay? And here, if I convert it into y equals to mx plus b form, I get minus x plus 7. So 7 is up high and minus x, right? So the other line will be kind of like this, right? And therefore, we get this point 2/5 where they will intersect. Do you see that? So those lines were intersecting lines and we got just one point of intersection. So if the slopes are same, then there are two possibilities. Either they will not intersect or they will intersect in all the points. So how do you find which of the two is right? By checking the y-intercept. If the y-intercept is same, then they're exactly same lines. But y-intercept is different, but slope is same, they're parallel lines and they don't intersect. I hope that helps you to understand linear systems in a better way. Okay? Thank you.